Hi, in this video I will be going over some tips to getting started with the sun path settings in Revit. Later on, I will demonstrate why this is a useful tool to maximize or minimize solar gains, which are a big factor in a building's efficiency. I will be using the Revit sample architecture project just to demonstrate these settings. Okay, so first if we just go into our 3D view here just so we can see our project. At the bottom of the screen you'll see the sun and this ball. I guess it's the moon, but let's just start with the sun. This is your sun path. Let's turn it on. This shows up, and this is, if you already have your project location set, you can just use this top thing. If you don't, I'll show you how to do that in a second. I'm just going to click on this top one because I know it's already set. And so here is our sun path for June 1st at 10 a.m. The sun's going to be at this location. We can change the date by clicking, say we want to say July 1st, and we can change the time the same way, or you can click and drag to see where your sun's going to be at different times of the year. And let's turn on the shadows as well at the bottom. And so this shows how the shadows are going to be displayed based on the sun's location in the sky. So we can use this to analyze our building and find out how and when the sun is going to be hitting our building. We can use this to determine solar gains, and we can use this to design based on the sun. If we want to, have a bedroom that faces the sunset, for example, such as this building, you can design around that. And in order to set the project location, if you don't already have that set, you go up here to Manage, and then Location. And this project is already set in Boston. I'm just going to go ahead and move that up here to Victoria. Here. That looks good. Okay. And another thing is you're going to want to make sure your project is oriented properly north. So if you don't have it oriented correctly, I know this is already oriented correctly, but you're going to want to make sure that your north is correct. So once you have those set, that's really all you need to know before getting accurate depictions of the shadows and sun location on your project. If you want to look into the solar study stuff, you can use this solar study tab here, and this will give you either like a still image or a single day, multi-day. Let's say, for example, single day looks like this. Summer solstice. This will show you the shadows throughout the day on this day, June 21st. Okay, so say we want to reduce the amount of solar gains we're getting on the hottest day of the year from this southwestern window. So I used this website here, Victoria Average Weather by Day, determined that August 1st is basically the warmest day on average. Okay, so I set the sun path to August 1st. And we can see that in the afternoon, this window, the southwestern window, gets a lot of sun. So we're getting a lot of solar gains through this window, which adds a lot of heat to the house and increases our cooling load. So if we make a little sunshade here, we can decrease the amount of sun getting in and lower our cooling loads. So let's go to our level 1 view and make a section at this window. This way we can get an accurate view of what the angle of the sun is coming through this window. Keep the far clip offset, which is this here, pretty far. I want to be able to see the sun path in the background. Let's go to this section. I'm going to turn the sun on. Do not crop view, I don't want to see that. sun path, we want August 1st at 1. Okay, so now we can get a good idea of the angle that the sun is hitting this glass. If you select the sun path, you can actually scale this down a little bit. I'm going to make this, okay, not 75, I guess 100. Just to keep things more compact here. So now, 1 p.m. on August 1st, let's reduce the sun coming through this window. To size an overhang, we want to draw a line up from here towards the sun. I'm gonna make another one. Oh, don't do that. Make another one from the bottom of the window up here, so we can see how the sun and what angle it's coming in at. Now, if I want to entirely get rid of all the sun at this time of day, I'm gonna need an overhang that's this far away from the window. It's a meter, 1098 meter, 1.1 meters. But it's not going to be right at the bottom, so I'm going to make it up here. So 1386. Let's say I have to expand this floor by 1.4 meters. So I'm going to do that here. Now, obviously you don't always want to just cantilever your floors like this, but for demonstration I'm doing this. You can also just draw another floor as a rectangle if you'd like. Okay. So now you can see we got this cantilevered floor. It's not beautiful, but for now it'll demonstrate what we want to show. So section 1, you can see now these sun rays are completely blocked at this time of day. Not entirely, but most of the way there. I mean, there's going to be some sun coming in from this angle too. So August 1st at 1. Okay, that's why it's not perfect. Okay, we got like 99% of the sun blocked. Okay. So that gives us a good idea of if we want to put an overhang here, we're going to need something that extends from the building about that far. About a meter. And we can see that if we change the day on the sun path to a shorter day, in the winter when we actually want sun coming in through these windows, let's say January 1st. The angle of the sun is much steeper here, right? So the sun is barely blocked at all by this sunshade. So we can minimize the solar gains in the summer with this overhang and still maintain a lot of sun coming through in the winter, which is what we want. So thanks for watching. Hopefully this video helped you understand the sun path tool in Revit a little bit better and how it can be used to design for solar gains. Thank you.